Okay, so this is the last section we're going to do in Module 6, 6.4, Leap Year, and this is a practice understanding task. All right. Carlos and Clarita are discussing their latest business venture with their friend Juanita. Carlos and Clarita, boy, they make a lot of money. They have created a daily planner that is both educational and entertaining. The planner consists of a pad of 365 pages bound together, one page for each day of the year. Oh, that makes sense. The planner is entertaining since images along the bottom of the pages form a flipbook animation. That had to be a little tedious to make. When thumbed through rapidly, the planner is educational since each page contains some interesting facts. Each month has a different theme, and the facts for the month have been written to fit the theme. For example, the theme for January is astronomy. The theme for February is mathematics, oh imagine that. And the theme for March is ancient civilizations. Carlos and Clarita have learned a lot from researching the facts they have included, and they have enjoyed creating the flipbook animation. All right, so the twins are excited to share the prototype of their planner with Juanita before sending it to printing. Juanita, however, has a major concern. Next year is leap year, she explains. You need 366 pages. So now Carlos and Clarita have the dilemma of needing to create an extra page to insert between February 28th and March 1st. Here are the planner pages they already have. So this is their image for February 28th. And remember, February is math month, so this is all math stuff right here. And then here's the image for March the 1st. And March is ancient civilizations, okay, and stuff like this. So they talk about in here how the Babylonians came up with 360 degrees in a circle. Pretty cool stuff. Read that if you're interested. Anyway, so Carlos and Clarita are going to have to create a page to insert for February 29th. But to have the flipbook work, they're going to have to make it look like when you thumb through that this house in the tornado is rotating to over here. So we probably need that house kind of right in the middle to make that happen. So let's think about how they could do that. Part 1. Since the theme for the facts for February is mathematics, Clarita suggests that they write formal definitions of the 3 rigid transformations they have been using to create the images for the flipbook animation. That's a great idea. How would you complete each of the following definitions? All right, so a translation of a set of points in a plane. Okay, so let's say we have a pre-image triangle ABC right here, and we want to translate that in the plane. Okay, what do we know? A translation. All right, well, here's our official notation right here. All right, and we have to do something to every x and something to every y. So in general, we could do something like this: x plus some number h and y plus some number k. So there's your general notation for any translation right there. So here's what we would like to do. Let's translate the pre-image triangle ABC to the image, which is triangle A prime, B prime, C prime, by this rule. XY is going to tend towards x minus y, y plus 2. Meaning, we're going to subtract 5 from every x coordinate and add 2 to every y coordinate. So I can take any one of these 3 points to get started, and I probably started with this A right here. So let's see. X minus 5. 1, 2, 3, 4, 5, and then y plus 2, 1, 2. So that point right there becomes A prime. Now let's do the same thing with B. 1, 2, 3, 4, 5, and then what do we go up to? 1, 2. So that point right there is B prime. And now do the same thing with point C. 1, 2, 3, 4, 5. There's my minus 5, and then up 2 right there. And that point right there is C prime. And then if we connect our vertices, we have triangle A prime, B prime, C prime. Note it is the same shape and size of triangle ABC, it has not been rotated or reflected. So that is the definition of a rigid transformation right there. Okay, now to a rotation of a set of points in a plane. Well, if we're going to rotate, remember, we need our point of rotation or center of rotation, all right? And we need an angle measure and a direction. So, let's see. Rotation implies rotate a preimage about a point, xy, by some angle measure, the measure of an angle. That's what that means. And we can rotate either clockwise or counterclockwise. All right, so let's see what they want us to do with this pentagon right here. Okay. By the way, that is a trapezoid because it has two parallel sides, all right? So we're going to rotate trapezoid ABCD about the point -2, 2. So let's find -2, 2. Here's the origin, -1, -2, and then up 1, 2. Right there. And we're going to rotate 90 degrees. So here's what we need to do here. Let's pick an anchor point. And I usually start with the simplest one, so I bet you I started with point C right here. Oh, no, I did the A right here. All right, now I'm thinking, all right, what is going on here? All right, to get from A to my point of rotation. All right, because we're doing 90 degrees, so just remember the definition of slope, okay? All right, so what is the slope of this segment? Well, it looks to me like you can't see it really well right there, but if I go down here, does it look like we are dropping 1? So a rise of -1, and then we're running 1? So there's the slope right there. Now you guys know the rule. To form a 90-degree angle, two segments must have slopes that are negative reciprocals. So the slope of the perpendicular then would be, well, the opposite of a negative number is a positive number, and the reciprocal of 1/1 is still 1/1. Just like that. All right, cool. So from our point of rotation, now let's think about which way we're rotating. Clockwise, good. So that means I got to go from this point of rotation, and I've got to go up 1 and over 1, and I'm going to put a point right here. Now, you guys, I can draw a line going through those 2 points, or a ray, like that right there. And then there's a couple things I could do. I could get my compass out and put the pointer right here and the pencil right there and do an arc. And if I do that very carefully, that arc will end up at my other point over there, the image of point A. Or I could do more slope stuff, and I could go like this. 1, 2, 3, 4, 5, 6. So we went 7 down, and we went 1, 2, 3, 4, 5, 6, 7 to the right. All right, so that's a -7 over 7. So how about we do this 7, 7. So let's go up 7. 1, 2, 3, 4, 5, 6, 7, and then go to the right 7. 1, 2, 3, 4, 5, 6, 7. See that point right there? I'll guarantee if you get your compass out and you do the arc, watch. There it is right there. So you can do that either way and do what you're comfortable with. But then now I know that this has to be a 90-degree angle, and this leg is going to be congruent to this leg over here. So that is my A prime right there. Okay, now we got to do that with B, C, and D. So I probably did B next. Let's see. Oh yeah, so here's my segment from point B to the point of rotation. Now I'm going to do more of the slope stuff because I think that's pretty easy. So let's look at the slope of this right here, okay? And let's be careful here. Let's go slope. Let's see if I did the whole thing. I'm going down 1, 2, 3. Hard to see with that there, but so let's be careful. 1, 2, 3. Double check. 1, 2, 3. Yeah, that's good. And then my arrow just disappeared. 1, 2, 3. And then, okay, I better be more careful than that. Maybe if I go up, it'll be easier for me. Right here, let's go up. 1, 2, 3. 4, 5, 6, 7. So it looks like I'm dropping 7. Yep. And then let's get down there. That would be right there. And then I'm going to the right. 1, 2, 3, 4, 5. Okay. So the slope of this segment is I'm rising -7 and I'm running 5. So a perpendicular would be then the negative reciprocal of this fraction right here, and the opposite of a negative is positive, and the reciprocal of 7 over 5 is 5 over 7. So that means I can do this perfect right here by just going up 5, 1, 2, 3, 4, 5, and then to the right 7, 1, 2, 3, 4, 5, 6, 7. There it is right there. And there's my other leg, and that is a perfect 90-degree angle, and those two segments would have to be congruent. So I can label that point right there my B prime. Now let's do this 2 more times, and we will have the perfect rotation. So let's go to C. And you got to be really careful here, because the segment from C to this point, it looks like it's right on top, but we got to count to make sure. All right, so I'm going -1, -2, -3, but then I'm only running 1, 2. Okay, so what is the negative reciprocal of -3/2? That would be positive 2/3. So now I go up to 1, 2, and I run 3. 1, 2, 3. And that point right there is C prime. Now one more time, D, and this one's going to be easier to see too. What's this slope of this segment right there? Well, I'm going rising -1, -2, -3, and I'm running 1, 2, 3, 4, 5, 6, 7. And you guys can tell me the negative reciprocal of -3 over 7 would be positive 7 over 3. So let's just go up 7. 1, 2, 3, 4, 5, 6, 7, and then go to the right 3. 1, 2, 3. And there we go, and that's D prime right there. And we've got another perfect 90-degree angle, and these two legs right there are congruent. So if I connect these vertices, A prime, B prime, C prime, D prime, look what I get. And that is, those two figures are congruent. They are the same shape and the same size. So that is a rigid transformation, and that is a rotation of my original trapezoid ABCD about the point -2, 2. All right, so a reflection of a set of points in a plane. So look at this one. They gave us a pre-image of a triangle ABC right there, and we're going to reflect it. So what are we going to reflect it over? I need to know the line of reflection. That's it. So a reflection, okay? Reflection implies reflect a pre-image over some line. Y equals mx plus b. Okay, cool. All right, so we're going to reflect pre-image triangle ABC over y equals -2x plus 2. So first thing you need to do is graph this line. And you see your y equals mx plus b, so that y-intercept is a 2. There's my 2 right there. And then my slope is -2, which means I have a rise of -2 and a run of 1. And I have that point right there, and 2 points determine a line. So that is the line y equals -2x plus 2. Now, when we reflect, all right, you know, just each of these points, kind of visualize it. This C would end up over here somewhere, C prime. A is going to end up over here, and B is going to end up over there. All right, so it doesn't matter which one we started with. So first off, though, the slope of our y equals -2x plus 2 is -2. All right, so when I do my reflection, don't I need the negative reciprocal of -2 over 1? Okay, so that implies the slope of the perpendicular would be, well, the negative reciprocal of -2 over 1 would be positive 1 over 2. So, let's do these slopes here now. I don't know which one I started with here. Let's see. Okay, I'm going to start with A. All right. Now, the line of reflection, or the line right here, has to have a slope of 1 over 2. Now, take a look at this, though. If I go up 1 and over 2, I'm going the wrong way. So do you guys agree that 1 over the 2 is the same thing as negative 1 over negative 2? Put a point right there. Right there. And now, I wonder if this works out perfect. It does not, darn it. So I just have to draw the segment right here, like that. And notice how I extend it, all right? Now, what I need to do is simply do this. I would measure this distance right here, and then I need exactly that distance on the other side. Okay, that is a 90-degree angle right there. And remember, the definition is this line has to be the perpendicular bisector of this segment right here. So I need exactly this distance on the other side. And when it doesn't work out perfect, you can estimate it using the grid, or you could just measure with a ruler. So I measured this with a ruler, and I am saying that the distance from this point to my line of reflection is exactly the same as this point to my pre-image right there. Okay, so I'm going to call that A prime. Now, I'm going to do the same thing with the other 2 points. So this B, I probably did B next, let's see. All right, I'm going to drop 1 and go to the left 2. Yep, and now I'll draw that segment right there, and then I just measure this distance, and by the way, that's a perfect 90-degree angle right there. Now I'm going to measure this distance exactly and put that on the other side, same distance, and there it is right there, and that is my B prime right there. Now one more time, let's go to point C, and let's drop 1 and go to the left 2, and then draw our segment. Okay, and now measure this distance right here and put that distance exactly the same on the other side. By the way, that's another 90-degree angle. And there it is, and that's my C prime. Now watch what happens if I've measured these very carefully. All right, I connect A prime, B prime, C prime. Look what I have. I have congruent triangles. That is a perfect reflection of triangle ABC over the line y equals negative 2x plus 2. And that is a rigid transformation because these 2 triangles, had I drawn them perfect, would be congruent. Okay, so did we cover translation, reflection, and rotation? I think we did. All right, so number 4. Translations, rotations, and reflections are rigid motion transformations because, well, we talked about it, I think, on every one of those. The congruent figures are the same shape and the same size. So in a rigid transformation, the pre-image and the image, these have to be congruent to each other. Okay? Meaning, again, the same shape and the same size. Congruent. And this is the symbol for congruent. It's an equal sign with a little tilde on top of it. Okay? Now, part 2. In addition to writing new facts for February 29, the twins also need to add another image in the middle of their flipbook animation. We talked about that right at the beginning. The animation sequence is of Dorothy's house from The Wizard of Oz as it is being carried over the rainbow by a tornado. The house in the February 28 drawing has been rotated to create the house in the March 1st drawing. Carlos believes that he can get from the February 28th drawing to the March 1st drawing by reflecting the February 28 drawing and then reflecting it again. So Carlos is conjecturing that 2 reflections can be the equivalent of 1 rotation. Wow. Verify that the image Carlos inserted between the 2 images that appeared on February 28th and March 1st works as he intended. For example, what convinces you that the February 29 image is a reflection of the February 28 image about the given line of reflection? So here's this graph now, and here's my line of reflection right here. And does it look like this house and this house? Let's call this the pre-image and this the image. Is this image a reflection of the pre-image over that line? That looks very good to me. Let's check a couple of them though. Okay, so reflection again. Reflect a pre-image over y equals mx plus b to the image. Okay, so if I took this point and I reflected it, it would end up right there at that point. Now we gotta do some slope stuff here. I hope I did that. That's point A, and it's gonna go there, and that's gonna be my A prime. All right, so implies y equals mx plus b is the perpendicular bisector of segment A prime. So if I do the segment A prime right there, do you guys agree that that looks like 90 degrees? And we can prove that. Okay, and you could prove that with slopes too. Let's see if that's what we did right there. Okay, yeah, use slope to prove the lines are perpendicular. All right, so here we go. Well, what's the slope of this line right here? Well, let's look at it carefully. I'm going to go where they intersect right there. I bet you I put a point right there. Let's see if I did. No, I'm just doing that. But do you guys see that I can go from this point to this point, meaning I'm dropping 2 and I'm running 1? So my rise is -2, my run is 1, which means the slope of a perpendicular would be positive 1 over 2. Now, does this segment have a slope of 1 over 2? Oh, that's perfect. Yeah, so they are perpendicular. Now, how could we prove that this segment is congruent to this segment? Well, it says use Pythagorean Theorem to prove segment A prime has been bisected. All right, so I'm going to picture these two right triangles for Pythagorean Theorem. And since there's so much going on here, I'm going to redraw the two right triangles I'm picturing down below here. So do you see like the right triangle right here? That's this right triangle. And then the right triangle here, that would be that right triangle right there. Now let's just put in our dimensions. So I have a height of 1 right there. And then what's this horizontal distance? That's 2. Okay, now I go to my other triangle and I hope it has the same dimensions. So this would be a 1 on the side. Oh, I did the 2 first. Let's see. Yep, that's 2 and that's 1. All right, so I see two right triangles here that have legs of 1 and 2. Doesn't that imply that they both would have to have the same congruent hypotenuse? So those C's, I believe, are congruent. All right, in fact, I know they are, and let's find out what they are with Pythagorean Theorem. So you guys know Pythagorean Theorem is a squared plus b squared equals c squared. All right, and the a would be a 1. 1 squared is still 1. The b would be a 2. 2 squared is 4, and that has to equal c squared. So let's solve this for c. So 1 plus 4 is 5. 5 equals c squared. And now to get rid of that square, you're just going to take the square root of both sides. So that's the square root of 5 equals c. So these diagonals right here are exactly root 5 units. We've just proven they are congruent. All right. Now, we might want to check one more anchor point. All right. So let's go at this point from C by the, what's that called, the weather vane right there. And that's going to this point over here. So I'm going to go B and B prime just like that, and I'm going to draw my segment. Now, I already know the slope here, all right, so I got to do my slope thing. Where am I at? Is that 90 degrees? I could use slope to prove it. Let's see if I did. Oh yeah, those two are congruent too. Oh, I did not, all right. So you guys, I didn't do this again, but can you agree that that is 90 degrees and that the distance from B to the line is congruent to the distance from the line to B prime? So that's a rotation or a reflection right there, and that looks perfect to me. Now we could check more anchor points and stuff, but I guarantee it's going to work. All right, so we've answered the first question. Now what are they asking? What convinces you that the March 1st image is a reflection of the February 29 image about the given line of reflection? So what Carlo's conjecture was, if I take this house and I reflect it over this line, It'll end up right here. And then he's picturing taking this house and reflecting it over this line to end up right there. So he's picturing drawing this middle house for February 29 in his flip book. But we've got to show that this is also a perfect reflection over this line. So again, pick an anchor point. All right, we'll go here and we'll call that point C. And then right here, I'd call that C prime. All right, so let's see. Doesn't this line need to be the perpendicular bisector of segment C, C prime? Okay, and I wrote that down right there too. So I want to know, is this a 90-degree angle? And does the distance from C to the line equal the distance from the line to C prime? Okay, and we can prove that just like we did on the other one here. Okay. Okay, oh, here's another house here too, or another anchor point right there, and that's right at the bottom of the chimney. So where is that? Is that right in there? There you go. Same thing. Does that look like 90 degrees? And does this distance look equal to this distance over here? Now I do want to figure out a couple of those. So let's do it. What's the slope of this line right here? Well, let's just pick a couple points. How about a point right here and right here? It looks like I'm rising 2 and I'm running 1. So that means the slope of the perpendiculars would have to be -1 over 2. Now, let's just pick one of these. Does it look like -1 over 2? I'd use this one. I'm dropping 1 and I'm running 2. Yeah, that works. So I know those have to be 90-degree angles. And then a little Pythagorean Theorem again here, and I did the little triangles and I drew them down below, but I'm picturing the triangle right here, that right triangle, and then this right triangle right there. And did those two right triangles look congruent to you? Well, let's put in our dimensions again, and this would be a 1, and this would be a 2, and here I'd have a 1. Oh, I did the 2 first. There's the 2. And there's the 1 right there. And again, we have 2 right triangles with legs of 1 and 2. That tells me those hypotenuses would have to be congruent to each other. And we'll find them. Are we going to get the same thing again? So a squared plus b squared equals c squared. Okay, so that's going to be a 1 plus 4 equals c squared. 5 equals c squared. Take the square root of both sides. Root 5 equals c. So the segment from C to the line is root 5, and the line to C prime is also root 5. It worked. Okay? Now, what convinces you that the two reflections together complete a rotation between the February 28 and March 1 images? So now we want to see if those two reflections create a rotation. Okay, and does it look like our February 28 image has been rotated to get to the March 1st image? It really does. And in fact, if we reflect over 2 lines, that is equivalent to, do you see where those 2 lines intersect? Right there. A rotation about that point. Okay, so a rotation. Rotate a pre-image about a point by some angle measure, clockwise or counterclockwise. So I'm picturing an anchor point and my point of rotation. Here's my anchor point. Here's my point of rotation. And let me see. What would the image of A be after the rotation? That would be this point right over here. And this 1812 is my point of rotation right there. That's the point where those 2 lines intersect. So if we do our segments here, there it is right there. Does that look like a good rotation? And I'm going to be honest with you guys. This does not work out perfect when I checked it. And I'm conjecturing it doesn't work absolutely perfect because this grid, my horizontal distance is not the same as my vertical distance, okay? And that's the publisher. That is not a perfect square grid to do this, but they're going to be very, very close. So it looks to me like, what is the measure of angle AI A prime? Well, You know what? I actually got a protractor out and I measured this distance right here of this angle right here, and I got 113 degrees. Okay? And then AI would have to be congruent to IA prime. Okay? And again, I did Pythagorean Theorem and I did it twice, and they weren't exact, but again, I think it's because the grid is not perfectly square. That's the only thing I can figure out. But anyway, let's practice this. So, this right triangle right here, we're going to go Pythagorean Theorem. Okay? So, you know, the vertical and the horizontal, we can see those pretty easily. So, a squared plus b squared has to equal c squared. So, I don't know, did I use a 1, 2, 3, 4 for my a? So 4 squared would be 16. No, I did the other one first, so let's do this. 1, 2, 3, 4, 5, 6, 7, 8, and 8 squared is 64. And then the b squared is 16, and that has to equal c squared. So 64 plus 16 is what? 80. So 80 equals c squared. And then I take the square root of both sides to get root 80 equals c. All right, so I'm going to say that this distance is root 80. Now, we do the same thing with another anchor point. Okay, and let's see. We'll draw the segment. Where is that over here? We're going to reflect about this point I, and that's the weather vane point, which is right over here. So there's B, and there's B prime. And I draw these segments right here, and I measured this again, and guess what I got for the measure of angle BI prime? Yes, 113 degrees. All right, and then a little Pythagorean theorem again to find one of these, and I use this triangle right here. So I'm going to go, all right, and I don't know which one I called A or B, but let's see. 1, 2, 3, 4, 5, 6. 6 squared would be a 36. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And 11 squared is 121. And that has to equal c squared. This distance right here is squared. Well, 36 and 121, let's see, that'd be what? 157 equals c squared. So square root of both sides, the square root of 157 equals c. Now, when I did that on the other one, it wasn't exactly perfect. And again, I'm going to conjecture because this is not a perfectly square grid. But I got the 157 square root of 157 units right there. So, and we're doing a rotation about point I, which is 1812. And which way are we rotating every time? Clockwise, 113 degrees. There you have it. Okay, getting back to the end of that last slide. Okay, I had to excuse the class and we were between classes, so I kind of rushed through this right at the end to help out a few students before they took off. But again, now this is the last slide actually on this entire presentation, and I thought there might be more too. All right. But what did you need to get out of this? You've got to understand that a rigid transformation is a pre-image either being translated, rotated, or reflected, so its image is congruent to the original pre-image. And now you've got to be an expert on the notation for a translation and able to do it. You need to be an expert on the notation for a reflection and be able to do it. And then you have to be an expert on the notation for a rotation and be able to do it. And what Carlos discovered right here is that, and this is big in geometry, all right? A rotation is the equivalent of the reflection over two lines. So if I reflect and reflect again, that gives me the image of a rotation. And your lines of reflection, where they intersect, that will always be the point of rotation. All right, so you guys get your ready, set, go done for 6.4, and let me know if you have any questions. And you guys get really good at the three transformations, the three rigid transformations: a translation, a reflection, and a rotation. Have a great day.